For this problem, we're going to graph f of theta equals cotangent theta. We're doing this to find the parent function of cotangent so that we can apply transformations to it. We're going to graph from 0 to pi, and you could argue that these equals should not be attached to the inequalities because of what's going to happen in our graph, but I've included them for the sake of making it easier to plug them in on our table. So, plugging in these values to get an idea of what this parent function looks like, we're going to start with 0 and finish with pi. And at the halfway point between these, we would have pi over 2. The halfway point between these would be 3 pi over 4. And the halfway point between these two would be pi over 4. These 5 theta values on our theta axis, which we could refer to as an x-axis, but our theta axis will give us the corresponding y values or function values for cotangent theta that we can now graph. So if we plug in 0 into cotangent, we're going to get an undefined value, and that's why we've picked it. When we get an undefined for cotangent, that means that we have a vertical asymptote. When we plug in pi, we will also get a vertical asymptote. These other values may not all be quadrantal angles like we've dealt with sine and cosine, but we can still use them easily because they are unit circle values. Pi over 4, when you plug it in, gives you 1. Pi over 2 plugged into cotangent gives us 0, and 3 pi over 4 gives us -1. Using these 5 values, we can graph them to get a good idea of the graph of the parent function of cotangent. So we're graphing from 0 to pi, so we'll put pi over here on our theta axis. And then halfway between 0 and pi, we will get pi over 2. Halfway between 0 and pi over 2, we'll get pi over 4. And halfway between pi over 2 and pi, we will get 3 pi over 4. At 0, we said there was a vertical asymptote, which looks like this dotted line here. At pi, there's a vertical asymptote. And one period of cotangent is going to lie between these two vertical asymptotes. So we have the point pi over 4 comma 1, which will be about here. And now is a good time to list what these marks mean. So from -5 to +5. Then we have pi over 2 comma 0. And then we have 3 pi over 4 comma -1, which is about here. Remember, when we connect these dots, it's not going to be a straight line. Otherwise, it's going to be some pointy edges and things like that. These follow a curve. So it's going to look more like a curve building up, a curve flowing down. And now remember, with a vertical asymptote, the graph is slowly approaching and then rapidly going up or down, never reaching it, but getting very close to it. So it's going to look something like this when we follow the vertical asymptote. And this is the graph of one period of cotangent. If we needed multiple periods, notice the period is a distance of pi. So if we just draw another vertical asymptote to the left or right, a distance of pi away from the other, and redraw this exact shape inside of it, we'll get a second period of cotangent, which we can repeat over and over and over again. So this is the graph of one period of the parent function of cotangent theta.